So let's extend our quadratic equation solving techniques to a more general case. So for instance, let's say we have x minus 4 squared equal to 25. Well, we can use the square root property on this. I mean, if this was x squared equal to 25, then I know that x is equal to 5 or negative 5. In this case, we have x minus 4 squared equal to 25. So this tells me that x minus 4 is equal to 5, or x minus 4 is equal to negative 5. And then from there, I would add 4 to both sides. And I end up with x equal to 9, or x equal to negative 1. So x minus 4 squared equal to 25 has two solutions. One where x is 9, and the other is x is negative 1. Now you can see this. Let's clear this off. If I was to graph y equal to x minus 4 squared minus 25, you can see that the graph crosses the x-axis in two places. So right there at negative 1, and right here where x is 9, which is the same answers we got before. If I want to try to solve 3y minus 7 squared equal to 64, well, I know that if x squared is equal to 64, x would be equal to 8 or negative 8. So in this case, what we'll have is we'll have 3y minus 7 equal to 8, and 3y minus 7 equal to negative 8. And then we solve each one separately. So for the first one, I would add 7 to both sides, and I'll have 3y is equal to 15. And then I divide by 3, and I have y is equal to 5. The second one, I would add 7, so I'd have 3y is equal to negative 1. And then divide by 3, I'll have y is equal to negative 1/3. So the solutions to 3y minus 7 squared equal to 64, there are two answers, one where y is 5 and one when y is negative 1/3. If I want to try something like 7 times 3x plus 1 squared equals 14, get the square part by itself first. So divide by 7. I'll have 3x plus 1 squared equal to 2. In this case, the square root property, if I had like x squared equal to 2, then my answer would be square root of 2 or negative square root of 2. In this case, I would have 3x plus 1 equal to the square root of 2. And 3x plus 1 equal to the negative square root of 2. And square root of 2 is not a nice, neat number. This is about the best we can write it. So if I subtract 1, I would have 3x is equal to negative 1 plus the square root of 2. And then if I divide everything by 3, I'll have negative 1 plus the square root of 2 over 3. Which doesn't look particularly pleasant, but that's the best we can do for this problem. For the other solution, I would subtract 1, and I would have 3x is equal to negative 1 minus the square root of 2. And then if I divide by 3, I'll have negative 1 minus the square root of 2 over 3. Again, not really nice looking, but it's the best we can do for this kind of problem. All right, so one last one. Let f of x equals 3x plus 8 squared, and I want to figure out what values of x give you f of x equal to 6. So that's basically saying we take that 3x plus 8 squared and set it equal to 6. So the square root property tells us that this will be 3x plus 8 equal to the square root of 6, and 3x plus 8 equal to the negative square root of 6. And then, again, you solve each one separately. It's not going to be nice and neat. All you can do is subtract and divide. So if I subtract, negative 8 and square root of 16 do not combine. So the best we can say is that this is 3x is equal to negative 8 plus the square root of 6. And then if I divide everything by 3, I'll have x is equal to negative 8 plus the square root of 6 over 3. And again, that's the best we can do for that. We could approximate it with the calculator, but as far as exact answers go, this is the best we can do. For the other answer, subtract 8. I'll have 3x is equal to negative 8 minus the square root of 6. And then if I divide by 3, I'll have minus 8 minus square root of 6 over 3.